In 10.2, we're not going to be adding or subtracting polynomials, we're going to be multiplying polynomials. And so the first couple of examples are just the distributive property, but we have to practice what that looks like when there are other terms, or other parts to the terms. So looking at one right here, when you do the distributive property, the rule is you multiply the numbers or the coefficients. So you do 3 times 7 gives you 21, and then x times x to the second, the rule is that you add the exponents. So x times x to the second is going to give me x to the third. When I do the second part, 3 times 8 gives me 24, and then x times no x's gives me x. So again, you're multiplying the coefficients, but then you're adding the exponents. And so when problems involve 3 terms on the inside, we'll be doing the same thing. It's still the distributive property, we just have to make sure that it lands on each of those. Be careful because this one's a negative. So it's going to be negative 1 times 9. So negative 9x to the 7th. Remember, you're adding the exponents. Negative times a negative is a positive. Negative 1 times negative 2 is positive 2x to the x to the third, and x to the third is x to the 6th. And then negative 1 times 7 is negative 7, x to the third. And that would be the answer for this one. So again, the number out front, or the term out front I should say, is getting multiplied to each of the different parts on the inside. This one has 4 terms on the inside, so my answer is going to have 4 parts to it. Let's see. This one will give me 2x to the 6th plus 6x to the 5th minus 4x to the 4th plus 10x to the 3rd. When you multiply these, your eyes end up doing a lot of back and forth because you're looking at the number out front and then the number that's in front of the one you're timesing it by, and then you're going back to the number that's in the exponent, and you're looking at the number in the exponent that you're multiplying by. So it's a lot of back and forth that your eyes do. It's always a good idea to go through at the end and check to make sure that you didn't make any mistakes with your exponents. Sometimes when you're doing the distributive property, there's going to be 2 separate parts where you have to do the distributive property. So on letter B, I'm going to do distribute with the 3c to the third, but then over here on this part, this parenthesis stops. So that means that this one stops distributing. I'm going to take this negative c and I'll do distribute. So I have 2 sets of the distributive property to do, and I'll start by doing that. And now I'll talk through this work. So 3 times 8 gives me 24, and then 3 c's and 4 c's gives me 7 c's. This one I get negative 9c to the 4th. Remember, you're adding the exponents together, plus 3c to the 3rd, because you're just multiplying it by a 1. You really want to be careful when you do the second parentheses, though, because you're multiplying everything by a negative c. So negative c times 6c to the 6th is going to give me minus 6c to the 7th. Negative c times negative 2c to the 3rd will give me plus 2c to the 4th. And then negative c times positive 7c to the 2nd will give me negative 7c to the 3rd. Once you've done the distributive property, then you're going to go through and see if there's any like terms to combine. On the first example here, there wasn't any, but on this one, I have things that I can combine together. So 24c to the 7th and negative 6c to the 7th can combine because they both have the same variable and the same exponent. And so that'll give me 18c to the 7th, and then negative 9c to the 4th and positive 2c to the 4th. So that gives me negative 7c to the 4th. And then 3c to the 3rd, take away 7c to the 3rd, will give me negative 4c to the 3rd. And so here, this one right here, that's my final answer. I can't combine anything else together because remember, you can only combine like terms when the variables have the same exponents, and all of these 3 exponents are different. So the other kind of multiplying that we're going to be doing in the notes today is multiplying binomials. Binomials mean that they have 2 terms, and so when you're doing this, it's a little bit different because it's not one thing being multiplied to everything like in the distributive property. It's 2 things being multiplied by 2 things. To multiply each term in the first binomial by each term in the second binomial. That's what it means when you're multiplying binomials. So there's 2 ways that you'll see this done. Some teachers teach this box method. Most teachers teach it this way though, with FOIL. FOIL is like doing the distributive property twice. So I take the first number, the 2x, and I multiply it by the x, and I multiply it by the negative 4. So 2x times x gives me 2x squared, and then 2x times negative 4 gives me negative 8x. And then I'm done with the 2x, and I move on to the 3, and so I still distribute the 3, the positive 3, to this part and to this part. So this part gives me 3x, and this part gives me 12. Some teachers call this FOIL because you multiply the first two together, and then you multiply the ones that are on the outside together, and then you multiply the ones that are on the inside together, and then you multiply the ones that are the last together. It's just a different way of understanding it. Usually there will be two terms that can combine together, and so in this one you get negative 8x and positive 3x. The box method's a little bit different. I would recommend asking your teacher questions about the box method if you want extra practice with this one. When you do the box method, you put two numbers on this side of the box, and then you put the other two numbers on this side of the box, and then you fill those boxes in by multiplying together each number. So these two times together go here, and then these two times together go here and here and here. You combine like terms, and so you do this. It's the same answer. It doesn't matter which of these two methods you use. I would recommend trying to be consistent, but they both give you the same answer to the question. Many times when you multiply together a 2 by 2, your answer is only going to have 3 terms in it. It's going to be a trinomial because 2 of the terms will combine together. We're going to practice more examples of this on the next page of notes. In my notes today, I won't be using the box method. I'll be using the FOIL method, but you're welcome to try them with the box method if you feel like you understand that method better. This is what the work's going to look like. So find the simpler form of each. It means I'm doing multiplication. So I multiply the first two together. That gives me 3a to the second. And then I multiply the outside ones together. That gives me plus 4a. Multiply the inside ones together. That gives me plus 6a. And then I multiply the last ones together, and that gives me positive 8. And then the 4a and the 6a combine together, and it gives me 10a. And so that's my answer. When you're doing the multiplication, you just want to be careful that you don't miss a step. So if you're multiplying together 2 by 2, 2 times 2 is 4. So before you combine anything together, your answer should have 4 parts. Let's do this one together. 3a times a is 3a squared, and then 3a times negative 2 is negative 6a. Positive 4 times a is positive 4a, and then positive 4 times negative 2 is negative 8. There will usually be 2 that can combine together, and so on this one, I'm going to get 3a squared minus 2a minus 8. If one of your binomials has a negative in it, you just want to be careful because your answer could have negatives in it as well. And then on letter C, I'll multiply together the first ones, the outside ones, the inside ones, and the last ones. So this one, x times 2x will give me 2x squared. X times negative 5 will give me negative 5x. Negative 3 times 2x will give me negative 6x. And then negative 3 times negative 5 will give me positive 15. You want to be really careful with that positive right there. These two in the middle will combine together. That's kind of a pattern. You'll see that happen a lot. So 2x squared minus 11x plus 15. And so that'll be my final answer for that question as well. Be careful. You can't combine these two parts together or try to add anything else together because you can only combine the ones that are like terms. They have to have the same variable and the same exponent. Anytime you see one of these 2 by 2s, you know that you're going to need to FOIL to answer the question. These ones are a little bit tricky though. Sometimes students think when there's a squared here, they can just like shower the power and give the squared to each of these, but that's in fact not true. Whenever you see a squared, what I recommend you do is cross it off and then rewrite the thing that you're multiplying. So when you see a squared, you're going to cross it off and then you're going to rewrite the thing that you're multiplying, because whenever something's squared, it means it's being multiplied by itself. So once you cross the squared out and write it twice, then you just do the same thing that we practiced before. So I'll multiply first, outside, inside, and last, and then I'll do the same thing on this one. I'll just get the arrows out of the way now. First, outside, inside, and last. 3m times 3m is 9m to the second. 3m times n is 3mn. n times 3m is another 3mn, and then n times n is n squared. And so on this one I can combine my like terms, and I'll get 9m squared plus 6mn plus n squared. And similarly on the last one, 4x times 4x is 16x squared. 4x times negative 3y is negative 12xy. Negative 3y times positive 4x is negative 12xy. And then negative 3y times negative 3y is positive 9y squared. And so on this one, again, the two in the middle usually add together. I'll have 16x squared minus 24xy plus 9y squared. That'll be my final answer for that one. It's tricky sometimes when they have more than one letter. It kind of feels a little bit like alphabet soup. But just be careful and make sure that when you do the first step with the arrows, you should always have 4 things here. And then usually speaking, 2 of them will combine together. Like on this one, the 5x and the 5x combined together and it turned into 10x. And on these last 3 examples, it's not that you have to cross one of them out and write it twice, it's just that something a little bit different happens when you're doing your work. So when you do the first outside inside last, you get x squared minus 2x plus 2x minus 4. When you combine negative 2x and positive 2x together, they cancel out. They turn into 0. And so I said usually your answer will have 3 parts, but on this one your answer only has 2 parts. And that's something special that's going to happen anytime they look like they're almost exactly the same, except one of them has a positive and one of them has a negative. It's called a difference of squares. So let's see. When I multiply together this one, 2x times 2x is going to give me 4x to the second. 2x times negative 3 will give me negative 6xy. 3y times 2x is going to give me positive 6xy. And then positive 3y times negative 3y is going to give me negative 9y squared. And so on this one, it's the 2 in the middle that combine together, but they happen to be opposites, which means they eliminate. So it means that your answer for this one is just going to be the first part and the last part, and that'll be the answer to the question. So similarly on F, 4a times 4a is 16a squared. 4a times b is 4ab, and then negative b times 4a is negative 4ab. And then negative b times positive b will give me negative b squared, and then the 2 in the middle cancel out with one another because they're opposites, so when they subtract they go away. So 16a squared minus 1b squared, that'll be the answer for this question.